Professor Lobster. There's a wise old man from the bottom of the sea. He's come to help both you and me. How things work and how things go. Anything you want to know. So if you don't know, I want to know. If you don't know, I need to know. If you don't know, I've got to know. Professor Lobster, Lobster, build a house for me. Somewhere I can go to watch my TV. Professor Lobster, Lobster, show me something new. Maybe when I'm older, I'll know as much as Professor Lobster.
All helpers, pay attention. I'd like the red ones to move where the black ones are, and I want the black ones to go where the yellow ones are, so you're only doing positions. Do it quickly, or do it again, please. Settle down now, quiet, please. Welcome to the Professor Lobster Show.
Yay!
Ah, Spaghetti del Ponte.
So what's on the show this week, Prof? Is it turned into a cooking programme?
No, it's about bridges and how they build them. And I'm going to show you spaghetti like you've never seen it before.
Oh, so let's see what's on the menu.
Well, on the menu this week, we've got cast iron, an 18th century material, served hot and cold. And we've got the wonder material of the 19th century, steel.
But what's all this got to do with bridges?
Oh, a lot. Wait and see. We're also going to build a cantilever bridge out of human beings using the helpers.
Have you asked them if they mind?
No, I haven't. They won't mind.
They might.
Do you?
Yes!
Well, you'll do it, I'm sure. The other thing we've got to do is build bridges out of spaghetti.
Spaghetti?
Yes, out of spaghetti.
I'm seriously thinking about looking for a job on another programme. This professor thinks it's a cooking programme.
What was that?
I said it sounds like a lot of fun.
Good. I'm glad you agree. Now, finally, we're going to have the Professor Lobster Suspension Bridge building competition. Great prizes for you.
What prizes?
Well, like last week.
Didn't get any.
Oh, well. Now, we're going to go and look at the art gallery.
This is just a rusty piece of old metal, though.
Ah, but look at this piece of cast iron with its beautiful detailing. Look at it.
Is it carved?
No, it was cast. It was a hot liquid once, molten metal, that was poured into a mould, a bit like a jelly mould.
First of all, spaghettis, and now jelly. This really is a cooking programme.
Here we are, a cast iron jelly factory. This iron foundry is like a kitchen. They mix up all the ingredients, cook them on a high flame, and it comes out looking like this. Okay. Right, Bill. Yep. Now what we're doing now is pouring it into the mould. It's taking the slag off the top, the impurities that would be in the iron as it goes in, and we're going to pour it into this mould, which is made out of sand, sea sand, and some red sand with clay in it, with some water to make it moist, and some coal dust inside. And the coal dust keeps the cast iron live. It stops it going off in the channels as it runs round. So there's a lot of skill in casting. And this new material, cast iron, which could be poured and shaped, was used to build the first iron bridge in the world. And they called a town after it.
What, cast iron?
No, Iron Bridge.
A horse and cart's all very well, Professor, but it's not very modern, is it?
Well, you have to understand old things before you can understand modern things.
But we need something like a car, preferably a red one.
Why do you want it to be red?
Because it would go with your suit.
Well, I suppose so. Get up. This used to be a toll bridge and it cost threepence to go over with a horse and cart. It's also a very interesting piece of history. Come on, get up. Whoa! Now, whoa! Stand. What we're standing on is part of the Industrial Revolution, the beginning of the cast iron age. Well, what do you think?
It's all right.
It's more than all right. It's living history, this. We can still go over it. Erected in 1779, this bridge was one of the first pieces of cast iron construction. It spans the River Severn, and it really was a leap into the future when they did it. It was a new sort of technology, a new material being used in a very imaginative way. Very, very exciting, I think. I think it was one of the best things they did that century. A leap into the future. Come on, get up. Get up there. Go on. How do you make a jelly?
Oh, we're turning into a cooking programme.
No, tell me how you make a jelly.
Well, you get the jelly, you pour some boiling hot water on it. It's got to be boiling.
Yep.
And you put it into a mould to set.
Well, cast iron's the same. You put it into a mould, it's cast by the mould. And the interesting thing about a new technology is sometimes they don't know how to do it. And they're exploring and they use technology of an older material, because this looks like it's made out of timber in some ways. The shapes are like bits of timber. It's arched and it's got braces, and what we've got is a dovetail at the end here with a bolt through it like a peg in a piece of timber construction. And this member slots through this, and they're connected by a big strong wedge. And this column, which goes right up to the top there, has holes in it which the arches thread through. And over the years this bridge has been repaired, patched and mended. It's over 200 years old, and it stood the test of time very well. Now here we are again with compression and tension. This weight is pressing down on my arm and it's under compression. And if I let it hang down, this arm's being stretched, it's under tension. Now if I hold my arm out, it's called a cantilever, and the weight on the end of it's difficult to hold. What do you think?
It sure is.
Well, give me a push. Now when you push me, I fall over very easily. But if you give me that other weight, and I put one on each arm, I become what's called a balanced cantilever structure. Now push me now. I don't push over as easily. Partly helped by the fact I've got my legs spread. But let's have a look at this bridge over here. This is a diagram of a very famous Victorian bridge, a steel bridge across the Firth of Forth, carrying a railway line. And it was 521 metres across there. And what it did, these were where the supports were coming out of the riverbed. And there we have, you do that on the other side, a very, very good example of a balanced cantilever bridge. Now what we're going to do is use some Victorian engineers to show the same principle. So come on. Now, you sit down there and you take hold of these supports, hook this on the end. Now this weight on the end is very important because that's restraining that end. The same at the other. And what we've got here, straight faces please, remember you're Victorians. We've got the arms working in tension, and this member here is working in compression. Well, this is all very well, but it needs to carry a load, doesn't it? So let's have the beam for the middle. Thanks, Liz. In this case, it's a seat, and what we're going to do, remember to hold it steady, let that down just a little bit. There we go. Hold it square and steady. Let's have another engineer, please. Fantastic moustache on this one. I like that moustache. Now, are you ready? Up we go, up. And sit there, steady. How are you doing? Is it painful? Yes, I thought it was fairly well balanced. You're looking as though you're doing a good job, straight face, please. Ready for the photograph, chaps? Okay, Victorian engineering at its best. And now for some suspension and a cheeky little red surprise for Liz.
Knock, knock. No, not hoot hoot, knock, knock.
Who's there?
Orson.
Orson who?
Orson cart.
Oh, that's funny. But don't rub it in. I've traded in the horse and cart, and we've got the Lobstermobile. What do you think of it?
It's great.
Yeah, it is, and so is this. This is the Clifton Suspension Bridge.
Way down there. It's a bit frightening.
It is, and it's an awful long way across. It's 230 metres across there.
230? Well, how's it held up in the middle?
Well, it's held up by those chains across the top. The chains go over the top of those pylons, that big stone pylon there, and the chains go across the river, and the bridge is held up from these rods that hang down from the chains. It's a suspension bridge. Do you like it?
Yeah, it's lovely.
I think it's fantastic. Probably one of the best bridges in the world. In fact, it's a triumph of Victorian engineering. Now, I'll take you to the centre of the bridge and show you where the chains are connected together.
Where's the centre?
This is the centre here, where there's these two bolts connecting the big chains together.
Chain?
Yep.
Call this a chain?
That's a chain, yes.
I call this a piece of metal.
Well, it is. It's lots of pieces of metal, but they're connected together like a bicycle chain. So they're curved and it can go up over the top of those big stone piers I've mentioned. Now, from the chain here, we've got these suspension rods that go down, and they hold the beam that you are sitting on.
A beam? I thought a beam was wooden.
Oh, no, beams can be iron or steel. These are iron.
Pa?
Yes?
Why am I moving?
Well, because the bridge moves quite a lot. Do you know it moves that much up and down if there's very big loads on it, about 300 millimetres, 150 up and 150 down. And it doesn't matter.
We're on it like that.
Well, we're on it now and it moves.
Yeah, no, but not that much.
Oh, no, not that. Well, we had a big load, but if we jumped up and down, it would move just a little bit. See? Can you feel it move?
Yeah.
It's moving now, I can feel it. Definitely.
Careful, you might crack the bridge.
Well, I think it's stronger than me jumping up and down. But bridges move all the time, up and down and sideways.
Prof! Prof! Where are you? What are you doing down there? Come up!
Full of interesting places, this. Where are you? Oh, you're there. Down here, there's a device to stop the bridge swinging from side to side.
Look, you said this bridge was safe.
Yes, it is. I'll show you it is. I'll demonstrate with an egg if you've got one.
You want an egg?
Yes, I'd like an egg.
Here you are. A lobster egg.
Well, that's a lovely egg. It's the right colour. Let's see if it'll break when we put it under something.
So what have you brought me down here for, Prof?
To show you this metal here, which is stopping the bridge from swinging from side to side, and also allowing for movement up and down.
What are you going to do with the egg?
Well, I'm putting it there. Next car that comes over should break it. Oh, I can hear it breaking just.
Broken.
It's coming out now. There, look at it. Bridges are very expensive structures, and when engineers design them, they like to use the best materials, and they try to use them economically.
In other words, no waste.
Yes, that's right, and it makes them light and elegant and good looking. Now, I did say we were going to build some bridges out of spaghetti.
Ew, it's all sloppy though.
Well, that's when it's cooked. Now, before it's cooked, see, if you take a piece and you pull it straight, it doesn't break. But if you bend it, it breaks because it's brittle. And if you take a short piece and press it, it's really quite strong. I'm hurting my fingers as I press this down. So if you use the spaghetti properly, if you design it properly, it may be possible to build bridges out of spaghetti. Now, we've had some bridges built by professors at Leeds University.
Professors of spaghetti?
No, professors of engineering. Anyway, we've got 3 bridges made. The first one here, this is a heavyweight bridge. And then, in the middle there, on this test rig, is the middleweight bridge. And finally, Liz is holding the lightest of the bridges, the lightweight bridge. And we're going to test all 3 of them. Now, first, on this middle one, I'd just like to point out, this is a lattice truss bridge, a bit like a timber roof truss in a way. It uses lots of little pieces of material, and the car is going to travel through the bridge. Can I have the car, please?
Oh, it's heavier than it looks.
Well, it's a diagrammatic car. It's made out of metal. It weighs about 1 kilo, as much as a bag of sugar. And remember, this is a spaghetti bridge, quite brittle material. You saw me snap it. Now, do you think it'll carry this kilo as it goes across?
Yes!
Okay, we'll give it a try. Ready, steady, go! Oh, just. This is the heavyweight bridge, the one that uses the most spaghetti. But when we look at it, you can see there isn't any diagonal bracing on the sides of the bridge, and there's only a diagonal brace at one end and one at the other. And it's a bit weak in the middle here. Can you see how it moves? But it's got strong beams at the bottom, so we'll see how it gets on. So this has used more spaghetti than either of the other bridges, and we'll test it. Oh, now it distorted and twisted and went out through the bottom. Now, this is the lightweight spaghetti bridge. You can see here that what we've got is a truss with triangulated members there at the side, and on the top we've got triangulations across, and also we've got triangulation there, diagonal braces across the bridge. That makes it a lot stiffer. Now remember, this is a lot lighter than the others, and it's going to be interesting to see if it will go across. Now, do you think the car will get across this one?
Yes!
Some are saying no, some are saying yes. The only thing to do is test it. Here we go. Oh, and it worked. Now we're going to look at another suspension bridge.
What, like Clifton?
Well, this one's younger and bigger. You could call it the grandson.
Or granddaughter?
Yes, that's right.
Look, Prof, there's a lobster part of
Yeah.
What, is that what you were born?
Well, there's lots of them all around the coast. There's all there from the holidays, isn't there?
Is it windy?
Yes, it's very bracing.
I bet you like this sort of weather because it's so wet and cold and
Great.
windy.
This is a river estuary. Do you know what that is?
No.
Well, an estuary is where the river gets wide as it goes to the sea, and the big problem with them is getting across them. How can you get across an estuary?
Oh, look, there's a ferry.
Well, that's true, a ferry. Or you could dig a tunnel. Or, better still, you could build a bridge like this. This one is much bigger than the Clifton Suspension Bridge, but it uses the same principles. It's got two great piers or pylons and steel cables which stretch across the river. The deck, here it's a steel box girder with a road surface on top, is suspended by a series of vertical cables. This is a modern version of the Clifton Suspension Bridge. Brunel would have been very proud of it.
So then, Professor Lobster, this is the end of the cable.
No, it goes a long way down there, and we're going to go and have a look at it.
Oh, smart.
This is the splay chamber.
What do you mean?
Well, the cable that holds the bridge up comes down and splays out here into separate sections that go down to the concrete foundation.
You mean that cable is this?
Yes, it's made out of lots of little separate galvanised wires. Do you know, there's 14,948 separate wires there.
Did you count them?
No, I didn't. The engineers calculated them, but it's very strong. It really is remarkable. It's like a temple, and it's a temple to tension. Now, they don't just stick the ends of these cables into concrete, they just pull away with the tension. What they do is they run the cables under this metal shoe, back round, and it becomes part of the main cable again. And it's adjusted by means of these big bolts with these huge nuts that go into the shoe. And similarly, down there's some more nuts in the foundation that goes down in there. So the whole thing is adjusted when it's being built and brought into tension as they're tightening it up. In fact, they tune the structure. What we've got here is a very nicely tuned structure. And now the best bit of the show, the Professor Lobster Suspension Bridge building competition. Now, what do we need to build a suspension bridge?
These things, chains.
That's right, chains, pylons, a deck, and some suspension rods. Now, you ready? Steady?
Go!
Black team. What's happening here is one side is building faster than the other, and it's very interesting because the curve of the chain is getting distorted, and it's very important that you build equally from both sides so that it's equally curved. So you'll have to wait for them to catch up. So wait for the other side to catch up now. Okay? Get the rods of an even length. Easy. Now don't panic. That's it, slide it in, nice. Now, nearly there, you're right. Put all your rods in. I hope you'll watch next week. It's iron and glass on the menu, and we're going to do time travel. Well, it sounds like a structural collapse over there with the yellows, and the reds have done it. Very, very good. Right, the prize is just some black licorice. Hardly amazingly expensive, but there you are, you've done well. Will you hold it, teams, for a minute? Just hold it. Now, camera 4, what's interesting here too, I want to show you this, is when you put a load on a bridge like this, it distorts in front of you. Now, it doesn't matter because suspension bridges move all the time.
Professor Lobster.